Okay, so what is the first that we have to look at?
So is whether it is regular or irregular?
Exactly, it's rhythmic or not. What do you think?
It's not rhythmic.
It's not rhythmic. Okay, the next one, we should figure out the heart rate. Okay, because it's not rhythmic, you have to make an average. Okay, this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Okay, how many we have? 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8.
And
We do have 8 within 5 seconds. You have to multiply by 12. It's
12.
meaning that you have
About 100.
okay, 96, 100, doesn't matter. Okay, so we do have about 100 bit per minute. What is the next that we have to look at?
About the axis.
Well, first let's look at, okay, I send you a note and that's saying that, okay, first you should look at the impulse formation center. Okay, what is the impulse formation center? Is this a sinus rhythm or not? This is what you have to figure out. Do we have P wave in lead number 2? Nice round shaded P wave? No, we don't. Okay, this is arrhythmic and no P wave. All right. Now,
Yes.
if you recall what you see in the videos, I said immediately if you do have arrhythmia, no P wave, immediately you have to diagnose. What is your diagnosis immediately? Atrial fibrillation, atrial fibrillation. So you don't need to see the F wave, the fibrillatory waves. It's enough if you say, doesn't matter how wide the QRS is. Arrhythmia, no P wave, atrial fibrillation. If we do have arrhythmia with sinus P wave, that's sick sinus syndrome. If we do have arrhythmia absoluta with a different P wave, that's a multifocal atrial impulse formation. Okay, so immediately now I know that this is an atrial fibrillation. You don't need to talk about the morphology of the P because there is no P. You don't need to talk about the PR interval because there is no P wave, there is no PR interval. The next one, you have to concentrate on the QRS complex. First, look at how wide the QRS complex is.
It's about
Look at here. Can you see it?
Yes.
It's very wide. It's more than 0.1 second, meaning that we have wide QRS complex. What does it mean when we do have a supraventricular rhythm, such as an atrial fibrillation, plus a wide QRS complex?
There is a ventricular fibrillation.
No. We do have an intraventricular block. So we do have a problem with the activation of the ventricle. So there are two possibilities, right bundle branch block or left bundle branch block. How can you decide which bundle is blocked? You have to look at V1 and V6. You have to look at the right side leads and the left ventricle leads. Where you see a wide R wave, when it's meaning that that part of the ventricle activated later because the ventricle activation time is elongated. Where can you see the wide R wave here? In V1 or in V6?
V1.
So that's a right bundle branch block. All right. Now look at the axis. Now the axis is coming.
Can you say number 2 is equiphasic one?
No, number 2 is negative. Lead number 1 is positive. AVF is negative, and lead number 2 is negative. What does it mean?
Then it will be about -90.
Oh, no, not -90. It's be around between -30 and -90. So that's an extreme left deviation. Okay. Now, what does it mean when we do have an extreme left deviation plus a right bundle branch block?
No idea.
Yeah. Pathological left deviation can be due to, for example, anterior hemiblock. If we do have an anterior hemiblock plus a right bundle branch block, that is called bifascicular block. Yes, that's a bifascicular block. All right, 2 fascicles are missing. Especially when we do have a right bundle branch block, very frequently we could have an anterior hemiblock as well, because the same coronary supplies these 2 areas. The next one, you should look at how tall the R wave. So there is any ventricular hypertrophy occurs or not, but we do not see any big tall R wave or deepest in V1. So that's meaning that there is nothing. You do see ST changes here, for example, ST depression, but this is due to the bundle branch block, the abnormal conduction. So that's a secondary STT changes what we do have here. Okay, that's it, nothing else.
Okay.
All right, you should look at my videos. Okay, Neil, it's your turn. Come on, guys. Come on. Okay. Next one, okay. Afaf, you have problem with your microphone. You can write in the chat if so. Okay. Haruna Soki, or I cannot read it because, or I sharing my screen or not. So please.
Can I do then?
Yes, of course. Somebody should do it.
Hi, this is Sarah.
Hi, Sarah. I can see it, but only I can
Yeah.
see maybe 2 or 3 names.
I know. Basically, I'm not sure what I'm looking at, but
Doesn't matter.
I will
We are
try.
practicing. We are practicing.
Yeah.
That's it.
Okay.
It doesn't hurt.
Okay, so we have a rhythmic.
This is rhythmic.
Oh, yeah. When I'm looking at 3, it's rhythmic, isn't it? Oh, number 2.
No.
Oh, let 2.
Look at here. Look at here. Doesn't matter. This is 1, 2, 1, 2. The distance between these beats are not equal. So this is not rhythmic.
Okay, that one is not rhythmic. Rhythmic. And then that thing I have to think is a P wave.
No, it's not rhythmic. Okay, good.
Okay, it
now
is
another. Do we have a heart rate? You should calculate the heart rate.
Yes.
Okay, this is the next one. It is 1 second, 2 seconds, 3 seconds, 4. That should be enough. 1, 2, 3, 4, 5, 6, 7. It means 15 times 7. It means 105.
105. So it's
okay. So it's tachycardic.
Tachycardic. Yes, it is tachycardic. And the next thing is axis.
No, the next thing is the impulse formation center you started. Let's see, do we have P waves?
Oh, yeah. Now it's P waves. Good. We have P waves. Yes.
In front of every beat.
In front of, for me, yeah.
Here we have.
Yes.
Here not. Okay. Again,
so.
Un momento.
Oh, okay.
Igen, figyelek. Okay. Okay. Moment, please. Okay, please wait a little bit.
No worries.
Somebody knocked at the door. Okay.
I'm good.
I am back. All right. So
Okay, so
we do have P wave in front of every beat. No, we don't.
I have
Because-
a question. So do we consider the small peak, the front one is as our QRS complex?
No, let's look at. This is a P wave. Can you see it?
Yes.
That's a P.
Uh-huh.
That's a QRS. This is a T wave. There is no P wave in front of it. The QRS is wide. As you see here, this QRS is not the same than this one.
Yes,
Especially
yes.
if you do see, this is coming
Uh-huh.
earlier. Yes?
Ah, got it. Okay. So even the amplitude is different. That's a P wave of QRS and QRS as well. Okay, I got it.
Okay.
Yeah.
So what does it mean?
It
It
means
meaning that we do have a written, then when we do have every second beat comes earlier,
Mhm,
and
mhm.
this QRS complex is wider.
Yes.
Now, what does it mean?
1 to 2.
No. There's
No,
no
not
one
that
to
one.
do.
It's not 1 to 2. Oh.
No one to do. It is
What?
every second beat comes earlier. How do you call when a beat comes earlier?
A bit comes earlier.
Earlier. Okay. That's kind of arrhythmia, and because there's no P wave in front of that, so it's meaning that we do not have a normal impulse formation. So it has to be an impulse formation abnormality. So it's not a normal impulse formation, meaning that this is a early coming bit. How do you call an early coming bit?
Premature.
Yes. And what is the
Oh.
origin of this premature bit?
Oh, the AV,
No,
the atrial.
not so.
Oh, sorry. It's like hard to understand what you're saying. Hello.
Okay, look. If you do have an
Oh,
early
much better.
coming bit,
Okay. Mhm.
if you do have an early coming bit,
Yes.
and the QRS is not the same, it
Oh.
cannot come from the same area as the sinus. It cannot come from the supraventricular area because the
Nope.
ventricle is not activated the same way.
Mhm.
It has to come from the ventricle.
Yes, it is. Yes.
So,
It's premature
what does it-
ventricular.
exactly. So that's a premature ventricular beat.
Yes, it is.
What does it mean? If you do have a, let's say, impulse formation and every second beat is a ventricle premature beat.
We're
What?
learning on the second. I don't remember the name.
That's a bigeminy. Ventricular bigeminy. Jesus, guys, you should watch the videos. At least the theories you should know.
I watched it, but it's hard to memorize the name of it. Sorry.
Okay, you should make some note, or you can download my notes as well, and you can use them. So this is a ventricle bigeminy. Okay. Now,
Okay.
when you look at the axis, you should use, let's see, the normal beats. And as you see here, that's number 3 is equiphasic. So the axis is around 30 degrees. Okay.
So you're saying number 3 is equiphasic?
Yes, I do say it because you can see that is nothing here.
No,
Yes.
there is no bit.
There's a beat, but exactly nothing. So 0. Okay, this is why that's an equiphasic in lead number 3. So it's perpendicular to lead number 3. This is why you have to assume that between 1 and 2, so it has to be around 30. Okay.
Thank you.
Good. All right, let's see the, no, not this one. Okay, let's see this one. Who is going to do this?
I'll go.
Okay, yay?
Yeah, it's me.
Okay, it's your turn. Great.
Okay. From the first one, I can say it is rhythmic
Okay.
and heartbeat about around 60 or Something about 65 or something like that.
No way, Jose.
Wait.
60 should be when you have 5 squares between the two R waves. How many squares we have? 1, 2, 3, a little bit more, 3.5. So it has to be between 75 and 100.
Okay.
So it has to be around 80 or 90.
Okay.
Okay,
Mhm.
go on.
And I cannot find the equiphasic ones. So
First, okay, leave out the axis first. Okay, please start to find the P wave. Is this a sinus written? This is the next question. Is this a sinus written? Do we have P waves?
yeah, we do have the P waves in front of it.
Okay, we do have P waves in front of every QRS. Okay, so that's a
And-
sinus. Okay, the next one, the PR interval.
PR interval. Yeah.
Mhm. Is the PR interval is normal?
I think it's around 0.12 seconds. So
Okay, so that's normal.
yeah, that's
All
normal.
right, so that's normal. Okay, go on. Next one, the QRS complex. Is it
QRS
wide?
is kind of wider than the normal ones.
Yes, that's wide again. We do have a sinus written, but the QRS is wide. What does it mean?
It can be delayed conduction.
Yes, inside the
Yeah.
ventricle, so we do have a intraventricular conduction abnormality. We could have a right bundle branch block or left bundle branch block. Yes.
Okay.
So, what do you think? Which one is this?
I think it's left ventricular.
Yes, because you do see the wide R wave in V6 or lead number 1 or AVL. Good, very good. Okay, the next one is
And
Q waves. Can you see pathological Q waves?
mm, I cannot really recognize the Q waves from the lead one, so
Lead number 1, no. But
Mhm.
what about here in V1 to V3?
okay, there's steep decrease in the Q wave.
How do you call this kind of wave?
Yeah,
That's
looks
a
like a ladder.
QS complex. QS complex. Okay.
Uh-huh.
QS complex is a pathological Q wave. Okay. Now,
Okay.
go on. What does it mean?
Wait, I just saw in the YouTube. What was it?
Hmm?
It's something to do with the fibrillations?
No!
No? Okay.
Pathological Q wave represents necrosis. Yes?
Necrosis. Okay.
Okay. But if you do have and left bundle branch blocks,
Mhm.
what kind of QRS complex you are expecting in V1, V2, V3 on the right side? What kind of complexes? Hmm?
More Q RS complex?
No, QS complex, because the septal activation is abnormal. So everything goes away from the right side and goes toward the left side. This is why that is going to give you a QS complex. And this is why in left bundle branch block, very difficult to diagnose an anterior MI. Okay,
Oh.
because normally you have QS complex.
Mhm.
Okay.
Okay.
All right. Now, and another thing that is important one, however, if somebody never had left bundle branch block And now, if the patient, together with the angina, has left bundle branch block, you have to consider as an MI. And additionally, very similarly, if you do here, you do have an ST depression. See, ST depression T inversion. This is secondary due to left bundle branch block. If you had an ST elevation, that could indicate an MI. Okay, MI always gives you an ST elevation, all right? Not ST depression unless you have a posterior, because in the anterior leads, you can have exactly the mirror image, so the inverted sign of the ST elevation.
Okay.
All right, next one. Who be the next one? Thank you. Homa, Hakim, Oval, anybody, please.
Hi. Yes.
Good. Your turn.
Okay. It looks rhythmic.
Okay.
Let me just count.
No.
The heart rate is maybe
This
72.
is rhythmic. This is rhythmic.
Yeah, and the heart rate is maybe.
Are you sure that is rhythmic? Look at
e-
here.
Yes.
QRS, and here, this distance is much bigger than this distance.
Yeah. Yeah.
So it's not rhythmic.
Oh, okay, so it's not rhythmic. Okay. But the other ones look kind of rhythmic. I didn't see
But
that one.
it's not rhythmic, not at
Yeah.
all. You have to look at the longer
Oh.
distance to see whether it's rhythmic or not. Between two beats, for sure, is rhythmic. But if you look at, for example,
Yeah.
5 or 7, it's not rhythmic.
Yeah, that's true. That's true. I counted the beats per minute being 72.
Okay.
Um,
Okay, go on. Do we have P wave?
yes.
Do we?
Yes.
Yes, we do.
Yeah.
Okay. And every P followed by QRS.
Yeah. It looks like it, but like some of the QRS don't.
There is no way that every QRS is every P followed by QRS. If you go step by step, please.
Oh, yeah.
Please. That's a P, QRS, P, QRS, P, QRS, P. Where is the QRS? There's no QRS.
Oh, yeah. I didn't see that bump. Yeah. P, QRS. Yeah, there's two P's there. I mean, no, there's a T and then there's a P. Yeah.
So
Mhm.
we do have a P wave that is not followed by QRS. What does it mean?
It's a second degree block of like.
Yes. And what kind of second degree block? We do have two types of second degree AV block, such as Mobius type 1 and Mobius type 2. How can you differentiate between Mobius type 1 and Mobius type 2?
Type 1, the PR intervals like get longer within the cycles, and then type 2, like every other P wave gets the PR wave intervals are constant within the cycle. So I think that 1.
But you haven't watched the video, because I said, look at the last conducted PR and compare to the first one. So this is a drop beat. Okay, there is no QRS. That was the last conducted one, and that's the first conducted one. So if the last one longer than the first one, this is Mobius type 1. If they are equal, that's Mobius type 2. Now, in this case, it's okay if you can see the elongation of the PR interval. However, if you do have an 8 to 7 conduction, there is no way that you will see the changes of the PR interval at the beginning. Okay, so please consider that that can be only use this phrase. Okay, last one, first one. Let's compare. Okay, go on. So that's Mobius type 1. Next one, let's look at how wide the QRS.
I'm not sure.
Is it wide or not?
I don't think so, no.
Look at here.
Yeah.
Is it only 2 millimeters? So it's meaning that 0.08. So that's normal. Okay. What is the axis?
The axis.
Yes.
Maybe it's
Which
negative,
is the equiphysical?
maybe negative 30.
Why?
Um,
The equiphysical.
because of like the 2.
No. Lead number AVF. Go all the way down. That's equiphysical. Lead
Oh,
number AVF is equiphysical. You have to look at least the 6 leads, okay? To see
okay.
whether there is, okay, now, so 6 leads. And you do see that this is equiphasic. So what does it mean if lead number AVF is equiphasic?
Yeah, 0.
What does it mean? That
That is 0.
The axis is around 0. All right, good. Next one. Is there any pathological Q wave?
I'm gonna look. I don't see any.
That will look like what is the definition of a pathological Q wave?
Sorry, I didn't hear the last thing you said.
What is the definition of a pathological Q wave?
Like it's basically like when
The Q wave should be wider and deeper than 1/4 of the R wave. Yes?
yeah,
Whenever we do
R
have a
is-
Q wave.
yeah.
Okay. What about here? This about 50% of the R. Yes, that's a deep one. Here, can you see this one? It's
Yeah.
very deep.
Yeah,
2, 3, and why do we have equiphasic Qrs complex in the AVF? Because the Q is the same size and an R. Yes, we do have pathological Q wave in 2, 3, and AVF.
Are those a sign of like myocardial infarction? The pathological.
Yes.
Okay.
Hopefully you are not asking, you are saying.
Yeah. Yes. Yeah.
Do we have ST elevation?
Let me see.
Can you see ST elevation where you have
Yeah, in number 2.
number 2, number 3? Yes, you do. What
Yeah.
does it mean?
It means when like there's a blockage of like an artery or like a heart muscle or like a partial.
No.
No?
It meaning that that's inferior MI is acute because you have a Q wave and ST elevation. This is what we are interested in, not the pathomechanism why the ST elevation develops. It's meaning that we have an inferior necrosis plus an ST elevation, that sign of lesion, but it says that, okay, that's an acute inferior myocardial infarction. That's it.
Yeah. Infraction. Yeah.
Okay.
Yeah.
All right. Good.
Okay. Thank
And
you.
why do we have ST depression in AVL?
ST depression in AV.
In AVL, why do we have it?
We have it when it's like below the baseline.
We do have ST depression. Yes. That's
Mhm.
you don't need to say it again with different word. That's an ST depression. But what does it indicate when we do have an ST depression in AVL? Especially when we do have an inferior acute MI. So why do we have ST depression?
It's also because of the
No,
No.
No, because AVL exactly opposite of lead number 3. That's a mirror image. If you do have ST elevation in lead number 3, you should have ST depression in the opposite side in AVL. If you do have ST elevation in AVL, you should have ST depression in lead number 3 because these two leads opposite to each other. Okay.
Okay.
All right. Okay, doc. Let's see the next one.
Thank
Wow,
you.
that's good. You're welcome. Let's see the next one. Cho, Ling Chu, Ling Jun, I don't know. Jang Hyun.
Yes, I'm here.
Okay, it's your turn. Rhythmic or not?
Yes. I can see that it's rhythmic,
Okay, that's rhythmic.
and heart rate is
It's around 90. Okay, go
it's
on.
around 90 BPM. Yeah.
Okay, go on.
And next, we have to look at the P wave. And lead number 1, I think there is no P wave.
Lead number 2, we should look at the P wave.
Lead number
Here.
2,
Yes,
yes, there is
and
negative P
AVR.
wave.
Okay, so exactly the opposite that we are expecting. Oh, that's great. What does it mean if you do have exactly the opposite of the P wave that we should see?
Mm,
Hmm? So, what do you think?
mm,
If we had a sinus written, the P should be positive in lead number 2, negative in AVR. Now we have the opposite. In lead number 2, we have negative, and in AVR, we have positivity. Now, what does it indicate? Where the impulse is formed. Hmm?
it's junction.
Yes, that's great.
Junctional rhythm.
That's a junctional rhythm, escape rhythm. Very good. That's a junctional escape rhythm. So what is the problem with these junctional escape rhythm? What should be the normal rate of the junctional escape rhythm?
Junctional escape rhythm.
Yes. What should be the rate of a junctional escape rhythm?
Slower than normal.
Yes, but how slow?
60, 50.
Around 40 to 60, 40 to 60. Yes?
Mhm.
And this
Yes.
is 90. What does it
Yes.
indicate? What does it indicate?
It's tachycardia.
Well, no, it's not a tachycardia over 100. And this
Oh,
is
yeah.
not
Mhm.
over 100. This is less than 100. So
Mm,
that's a junctional acceleration. This is how we
yes.
call it. Okay?
Mhm.
Junctional acceleration. Good. Without the QRS, is it okay?
Yeah, I think it's narrow.
Okay, good. Axis?
Axis, lead 1 is positive and AVF is equiphasic.
AVF. This is lead number 1. That's AVF. This is not equiphasic. If you want to choose an equiphasic one, it should be AVL.
Okay.
Not the positivity and negativity are about the same. So
it's around it's in normal axis.
yes, but how much?
It's around 60.
No. Well, okay, that's yes, you are right, because AVL is exactly perpendicular to 60. Yes, you are right, completely. Sorry. Yes, can be around 60. However, in lead number 1 bigger than lead number 3, so I would say around 50, a little bit closer to lead number 1. That can be. Okay, that's great.
Okay.
Okay, thank you very much.
Thank you.
Okay, next one, Mickey.
Yes.
It's your turn. So far, so good.
Oh, sorry. The connection isn't so good, so sometimes I cannot
Okay.
hear you well.
Okay, so the connection is not good. We cannot hear
But
you
like I
either.
try. Can you
Okay.
hear me now?
Yes, we can hear you.
And firstly, this is rhythmic.
Okay, good.
And
Now we can.
Can I hear you?
No, it's
I
it's
can't
not
hear
good.
me.
Okay, now I cannot hear you. That's okay. Nisi. Nisi.
Yeah, I'm here.
Okay, it's your
Okay,
turn.
sure. Well, first of all, I'd say it's
Rhythmic or not?
Yeah, rhythmic
Rhythmic.
first. Yeah.
Okay. Next one. Heart rate.
Heart rate, 1, 1, 2, 3. Like 3.5, almost 4. So
Let's make it 4. Let's make it
okay.
4. That's easy one. Okay.
Okay, so 4.
Yes.
So that would be 75.
Good. Go on. Do we
And then
have P waves?
yeah, in lead 2, we can
Yes.
see. I'm coming. Yeah, we can see P waves first of all, and they are appearing before each QRS. So
Very
like
good.
it's normal.
Okay.
And then let me see the interval, the PR interval, I would
Yes.
say is also same, like it's a bit wide,
Yes.
but same in between.
It's same but
Yeah.
longer.
Yeah,
What does
wide.
it indicate? What does it indicate?
A long PR.
Yes. Every P followed by QRS.
Rapidly
PR
followed.
is longer and it's rhythmic. That has to be a.
I'm not sure. Is it one of the
Where do you have the conduction abnormality? Between the atrium and the ventricle. These
yes,
are called
AV blocks.
AV block. What
Yeah,
kind of AV block is when we do have an elongation of the PR, but always P is conducted? How do we call that situation?
First of all,
Wait, I'm coming.
So say it. You see.
It's not secondary. That's
No,
what
it's not,
I'm thinking.
because everything is conducted. It cannot
Yeah,
be a
everything is
second degree
conducted. So
because
I'm trying
that's
to remember
arithmetic.
first of all,
the name for the first one is it? What's another word for primary?
First degree
First
AV block.
degree.
First degree AV block. Okay.
Yeah.
So we have a first degree AV block.
block.
Okay. What about, is the QRS is wide?
Yes, please, a bit. You can see
No,
it's a
it's
bit.
not a little bit. It's not wide. It's again 2 millimeters. It's not wide. You can see it. Okay, it's not
Yeah,
wide.
2 boxes. Okay.
What about the axis?
It's positive in lead 1, and is that an AVF? Yeah, I can see it's also positive in AVF, which is a left
It's right
deviation.
here.
Yeah, it's positive in AVF as well, so it's a left deviation. But if I look through the 3 leads, lead 2 is the biggest. So it's closer to lead 2. So that would
So?
be around where's lead 2? Around 60 double.
Okay, that's okay.
Yeah,
But look,
60.
in 1 is positive. AVF is positive. Is normal. It's not left
Yeah.
deviation. That's normal. And by looking at the high of the R in the 1, 2, 3, the standard interval is, you do see that lead number 2 is the biggest one. So it's parallel with lead number 2, so around 60. But
Yeah.
3 is bigger than 1. This is meaning that you have about 70 or 80. Okay.
Yeah, it's
All
between.
right.
Okay.
Good.
Thank you.
Next one. Can you
For
see
the V's,
pathological Q wave?
yes, it's sharper and dipping.
Can you see pathological Q waves?
Yes, please.
Where?
I can see dips from V1 to V3.
Yes, we do see
Uh-huh.
Qs complex in V1, V2,
2 and
V3.
V3. Yeah.
So what does it indicate?
It's a blockage, but it's
No, it's
the
not a
opposite.
blockage. It's not a blockage.
First of all, negative Q waves indicates like necrosis, like you said.
Yes. So,
Uh-huh.
so
What's the word for this? We already said it.
necrosis. What is the word for necrosis? Myocardial
Infarction.
infarction. Myocardial infarction. And what is a location?
Of the I see a little elevation in V2 and V3 because
But
it's
not
supposed
the
to be an
elevation,
ST.
not the elevation, not the elevation. Pathological Q wave can be seen in V1, V2, V3.
V3.
What is the location of this necrosis? The anteroseptal area. Yes?
Okay. Yeah. I remember the slide.
Okay. Do we have ST elevation here?
Yes, please.
Do we have?
Yes, because ST elevation would need is an indication for MI. After each Q dip,
How
there's a little
many
raise.
millimeters? How many millimeters of the ST elevation should be to diagnose infarction? At least 2 in the chest leads. Do we have more than 2? No, we don't.
No, we don't.
So what does it mean?
That it's a subacute MI or
That's a possible a subacute or old anteroseptal myocardial MI. Yes, exactly. Good. Now look at the ST segment. We haven't finished yet. Look at the ST segment, for example, lead number 2, lead number 3. AVF, AVL. How does it look like? It's a round shape. That's a scooped one. You should watch the ions and everything and ST segment. That's a digitalis effect. It can be a digitalis effect, okay? That is going to alter the ST segment, something like this, okay? Now we finished, okay. Oh, yeah, that's a good one. Okay, Homa.
Yeah, I already went, but I could go again.
Yeah, I don't know. Maybe Mao?
Okay.
Yeah, very difficult to hear you.
Can you hear me?
No, it's not good. Okay. Homa, let's go.
Okay.
See, you have a good connection. This is why I choose you. Okay, let's see.
Okay.
So far, so good.
Last time I thought it was rhythmic, but it wasn't. So I'm really gonna look at it.
That's rhythmic. That's rhythmic.
Yeah.
That's
Okay.
rhythmic.
Okay.
For sure, it's
It is
rhythmic.
Okay.
It's very much is rhythmic. Okay.
Yeah, I thought it was rhythmic too.
Okay.
1 second. Let me just count.
Mhm.
I don't see a P wave for each one.
Yes.
So
Okay.
no P wave.
P wave. What does it mean? If when we do not have any P wave.
It means like maybe like a sinoatrial arrest or something.
Okay, so that
Like
meaning that we don't have any sinus activity. Okay,
Yeah.
so there is no sinus activity. So it can be a 3rd-degree SA block or basically no sinus impulse formation. Only
Mhm.
what we have a QRS complex. But
Yeah.
when you look at this QRS complex,
Yeah.
they look bizarre. How
Yeah.
these QRS complex are started?
Mm. Like up and down.
It's starting with a very fast way. It's a spike. It's
Yeah,
initiated with a spike.
Yeah.
Now, what does it indicate when we do have a spike?
It means like when it increases,
What do you mean increases?
like the QR.
It makes no sense.
Okay, well, the QRS complex, like it represents the depolarization of the ventricles.
Yes.
So I think like if it's like I don't know.
But if you do have a ventricle escape rhythm,
Mhm.
it shouldn't be started with a spike. It shouldn't be started with this
Yeah.
rapid activation. So something is weird here. It's not a ventricle escape rhythm. This
Yeah.
is called artificial pacemaker.
Yeah.
They put a pacemaker into the ventricle. And this is why when the pacemaker is firing very rapidly, and
Yeah.
after the impulse is propagated to the QRS complex, and this
Yeah.
is why the first phase is fast, the next one is nicely round and elongated.
Yeah.
Okay, now, which ventricle they put the pacemaker in? So where is the pacemaker, this artificial pacemaker? Now, what do you think?
I think maybe in the right ventricle.
Because you have to explain why. It's not enough to say that maybe.
I think I just read it.
Okay, think a little bit.
Okay.
If you had a pacemaker on the right side,
Then
every impulse goes from right to the left.
to the left,
So
yeah.
the-
So have a
So the
left
main
block.
electrical axis on the left side.
Yeah.
Yes. If you had on the left side, everything goes from left to right.
Right. Yeah.
Okay. What about the axis here?
It's going from like right to left, I think.
You're going to right to the left. That's
Yeah.
very good. So we
Mhm.
do have a right ventricle implanted ventricular pacemaker. Very
Mhm.
good.
Thank you.
Okay. All right. Okay. All right. Now, see how.
Yes, I'm present.
No, say it again
Can you
because
hear me?
yes, I can hear you.
Cool.
So,
Give me 1 second. It's page 13. I would say it is regular rhythm.
okay, more or less. Yes, go on.
The heart rate is
Heart rate is
70-ish.
okay, around 70 beats per minute. Okay, that's good. That's not bad. It's normal. All right, go on.
And the PA,
Do we have periods? It's a good question.
it's like a F wave more.
Yes, very good. Wow, Jesus Christ, you made my day.
So
we do have a, yes, this is a atrial
Atrial
flutter. These are
fibrillation.
flutter, not fibrillation.
Sorry.
Because fibrillation is arrhythmia, no P wave.
Right.
Here it's rhythmic, and you do have this sound wave, this capital F wave. So capital F waves means flutter waves. Yes?
Mhm.
Okay, so that's an atria flutter. What is the conduction ratio? You can count, let's see, the 1, 2, 3, 4, 1, 2, 3, 4. So 4 to 1
4 to
contraction.
1.
Okay, what about the axis?
Yeah, so
Uh-huh.
1, there's no equiphasic, so 1 is positive.
What about
AV,
AVF? AVF, look at AVF, is almost nothing. Yes, we do have an equiphasic one in AVF. So
oh, it is equiphasic.
yes, that's an AVF is
So if
equiphasic. So
Okay, if AVF is equiphasic, I would say it's 0 degrees.
yes, that's normal, but how much is the axis?
0.
Yes, correct. Very good. Do we see pathological Q wave anywhere? No, no.
No.
No, because we have initial R. No, no, no. So there is no pathological Q wave, no MR. Great. Ah, yes. Ojan.
Yep.
Okay, your turn.
Okay.
Wow,
It
your
looks...
microphone is great. So you be the next one as well. Okay.
It looks rhythmic, I
Okay.
believe. Yeah. I don't think there's a P wave before each one.
No, but again, okay, very good. So it looks like there is no P wave, or we do have a P wave, but how this P is initiated?
Probably with an implanted pacemaker as well, because of the
Yes,
spike.
exactly. So this pacemaker is implanted into the atrium. Yes?
Yeah.
Very good. Now let's look at the PR interval.
I think it's elongated.
Okay, so it's meaning that this patient has a first degree AV block as well. Yes?
Yeah.
Okay, good. Don't go away. It's still your turn. It's still your turn. Yes, is yours. Okay.
It looks very fun.
I'm very glad that you have fun. All right.
It does look.
Is it rhythmic or not?
I want to say it is rhythmic, except for
Yes.
what happens at
Okay,
the
what
end
is
there.
that? Okay, what is this? What is this?
Yeah, that's
Very
what I was
good question.
confused about.
Now, what about this? What about this square signal? What can it be? What about this square signal?
Is it a elongated ST?
No, this is a calibration sign, 1 millivolt calibration sign. I think Afaf wanted to say it, yes? No, Afaf still has problem with the microphone. Okay, all right, so that's rhythmic, and these are calibrated. Don't forget, this is 1 millivolt calibration sign, and they usually put on the tracing. Sometimes they are using to separate the different leads. Okay, now let's go on. So we do have rhythmicity. Okay, next one.
I don't think there's a P wave in each one. For example, AVL doesn't look like it has any.
Okay, let's
APR.
see a little bit. Okay, look at this is a P, this is a P. Okay, in lead number 2.
Yeah.
If we do have P waves, and in AVR we do have P waves. Okay, so we have P waves. Don't worry. But what is a problem with this P wave? Especially if you look at lead number 1. What is the problem with this P wave?
Is it a very narrow, I mean, shortened PR interval?
So PR is short. What does it indicate when the PR is short?
It didn't have enough time for the polarization.
That's a bullshit. So when the PR is short, what kind of syndrome is this?
It would be a blockage, I believe.
Pre-excitation syndrome. If you have a blockage, the PR should be wider, but this is shorter, so we have a faster conduction through the AV junction. There are two pre-excitation type of pre-excitation syndrome that we learned. That's an LGL, when the P followed by a narrow QRS, or when we do have a wide QRS, and that's the WPW syndrome. So here, what we have?
This one would be an LGL.
This, look, is this QRS is wide?
Oh, I see. Yeah, that is wide. So then it would be the WPW.
And it started with the delta wave, yes? So that's a WPW syndrome. Which type of WPW syndrome we have? How can we specify the type of the WPW? Whether the cant is located on the left side or the right side. So
Sorry, what is located on the left or right?
the type, we have A type and B type. How can you differentiate whether this is on the left side or the right side? Look at V1. What you should see if it's located on the right side. It's meaning that the impulse goes from right to the left. So in V1, you have negativity. However, if it's located on the left side, everything goes toward the right side. So V1 should be positive. If V1 is positive, that's a A type. If V1 is negative, that's a B type. So that's a B type, yes?
Yeah, okay.
And what kind of arrhythmia can develop in a patient who has WPW syndrome?
It could be tachycardia.
What kind of tachycardia can develop?
This one would probably be the antidromic.
Okay, so AVRT tachycardia can develop, AVRT tachycardia, and when it's widening, that means antidromic or autodromic. These are the two different types of the tachycardia that can develop, depending on whether the canned bundle activates the ventricle and AV junction reuptake, or opposite one, the AV junction activates the ventricle and the can serves as a reuptake. Okay? Good. Very good. Okay. All right. I'm sharing another one. Okay, wait a minute. I'm going to share another tracing. Momento. Yes. Okay. Oh, yeah, that's great. I like it. Maybe you won't. Okay, good. Now let's see who is going to. Okay, who is going to? Oh boy, how can I share this whole thing? It's a problem. I'm on Control L. That should be. Okay, wait a minute. Yes. It doesn't want to do it. I don't know why. Okay. Yes, now it's okay. Okay. All right. Good. And the ECG goes to Letizia.
Hello, I sent you a message because I didn't revise, so I don't know
Okay. I couldn't read everything because a lot of people send me a message. Okay, Oyan or Ojan?
Yeah.
Okay, it's your turn.
So it looks irregular.
Okay, very good. Very good. Irregular. Okay. What about the rate?
The rate.
The rate is?
It looks like will be maybe around 90.
No, I think it's more. If you look at, for example, here it's around 150, 100, maybe 120, and here it's 150. So I think it's around 100. So it's depending on which lead that you are looking at, but I would say tachycardia. Okay. Next
Okay.
one. Do we have P wave?
I don't think so. Not in each one.
No, we don't have P wave. So what does it indicate immediately? Arrhythmia, no P wave.
Then it's a block. It would be, I believe, a second
This is
degree block.
no. That's an impulse formation abnormality. And which one? This was the first that we started with. Arrhythmia, no P wave. It has to be an atrial fibrillation. Please remember,
Okay.
arrhythmia, no P wave. Immediately you should diagnose an atrial fibrillation. So this guy has, or whatever the patient had, an atrial fibrillation. You don't need to talk about the P wave, the PR interval. Next is the QRS. Is it narrow or wide?
They look narrow.
Okay, very good. What about the axis? Okay, what about the axis? You can come here because we are in the QRS complex. What about the axis? It's maybe difficult to see it, but this is lead number 1, 2, 3, AVR, AVR, AVR. Which is the equiphasic one?
I think AVF would be equiphasic.
Very good. Okay. So
because of that, then it's going to be 0 degrees.
okay, very good. So 0 degrees. Next one. Pathological Q wave. Can we see pathological Q wave?
Yes, we see it in lead 3.
Okay. In lead 3 and
in AVF as well.
Okay. All right. And ST elevation as well. Now that's an ST elevation. What does it indicate?
The ST elevation.
Yes.
The
And to get
necrosis.
Q wave. No, ST elevation.
Oh, no,
lesion.
with the myocardial infraction with the.
Yes, but which phase? If you do have Q wave and ST elevation,
it would be acute phase, I believe.
Exactly, acute. So we do have an acute inferior MI, yes?
Yeah.
Okay, now let's move on. Let's look at the chest leads because inferior mostly accompanied with a posterior MI. Look at the chest leads, V1, V2, V3, V4, V5, V6. Anything that can indicate a posterior extension?
I believe V1 being negative.
No, V1 is RS. V1 is okay. V1 is okay. V2 is RS. But what will happen in the chest is normally we have a normal R progression that usually between V3 and V4 when the R is bigger than an S wave. And here, V2, the R is bigger than an S. So it's meaning we have a tall R in V2. All right. So prominent R wave that we can see in V2, V3. That's not normal. It's not normal. So that can indicate a Q wave on the back. Okay, because that's a mirror image. So it can indicate that this patient has an infero-posterior acute myocardial infarction.
Okay.
Capish?
And that's because you said V2, the QRS is greater than.
The R wave is big, too big. The normal progression, yes, in V1, the R is small one or nothing. V2, the R is getting bigger, the S is still deeper than an R wave in positive. And V3, the R is still smaller than an S wave. And V4, the R is bigger than S. So, and here it's indicating that V2 already the R is too big one. So, and because it's too big and the patient has an inferior MI, you can diagnose as a infero posterior acute myocardial infarction. Okay?
Okay.
Good. All right. Next one. Wow, great. Okay. Sinju.
Yes, I'm here.
Wow, nice microphone. Okay, do it.
First of all, seems regular,
Good.
and the heart rate seems 3 boxes, so smaller than 3 boxes, so it's below the 100 and between
Okay.
150.
120, 110 is fine. Because if you had 2, that means 150. But if it's, let's see, a little bit more than 2, and I bet you this is more than 2, yes?
Yeah. Yes.
Oops. Okay. Come on. Oh, Jesus. Yes, here. Yes, so that's about, if you do see here, all right, this is, where can I say? Yes, here, 1, 2, almost 3. So this is why a little bit faster than 100, okay?
Okay.
Go on. Do we have P waves?
Yes, I can see P waves in number 2 leads.
Okay, and negative in AVR, so, and every P
Yes.
conducted, okay?
Yes.
And the PR interval looks okay if I'm
Yes.
looking at, okay, good, go on.
And the axis. So number 1 is positive, AVF is negative.
Good,
So
and?
it's going to be left deviated, but
Lead number 2 is negative
2 is
as
negative.
well. So, and AVR is positive, so you know that.
Extreme deviation.
Exactly, so it's located between -60 and -90 because AVR is positive, okay?
Yes.
So that's an extreme left deviation. Good. Next one, pathological Q wave.
I think you see in V3.
Okay, we do see in V1, V1, V2, V3, together with ST elevation. Yes?
Yes, so it's
And we still have,
myocardial.
yes, and we still have in V4. So that can be an enteroseptal myocardial infarction. Which phase? That's in the acute because we have Q and ST elevation.
Okay.
Okay, now we have an extreme left deviation. What could be the cause of an extreme left deviation?
The cause.
What was the first ECG that we looked today? Right bundle block with extreme left deviation.
Oh, the bifascicular block?
Yeah, that was a bifascicular, but here is not a bifascicular because we don't have right bundle branch block, but we do have a extreme left deviation that is would be due to the anterior hemiblock.
Oh.
All right. So this
it's only for anterior hemiblock.
Yes. Okay. And then MI and enteroseptal MI, acute MI.
Okay.
Plus, look at V5, V6. What is the problem with V5, V6? I don't like this V5, V6. What could be the problem?
The Q and R seems similar.
The RS.
Yes.
The RS is similar. So S is too deep. What could be the reason why we do have a very deep S wave in V5, V6?
Is it from the last lecture?
Yes, but I told you to watch all the videos now.
Yeah.
All of them.
Okay.
So that's a hypertrophy. This can be the sign of a right ventricular hypertrophy. Well, it's true that in V1 you should see a tall R wave, but because we have an MI, that cannot be seen. Okay, so that's, if I summarize, this patient has a tachycardia, sinus tachycardia, anterior hemiblock, anteroseptal acute myocardial infarction, and a right ventricular hypertrophy. Okay.
Thank you.
Good. Okay. Now let's see who has this one. Okay, Luis. Louis.
Yes, can you hear me?
Yes,
Hello.
we can hear you very nicely. So hopefully you can solve this ECG very nicely as well.
Okay, so I think it's rhythmic.
Very good.
Is the axis the first lead? No.
Well, I said, first of all, the rate, heart rate.
I don't remember how to calculate it.
Well, if it's rhythmic, what you have to do, count how many big boxes you have between two R's. 1, 2, 3, 4, almost 5. So a little bit faster than 60. So that can be around 65.
Okay.
Okay. Now, next question. Do we have P waves?
No, or very small ones? Yeah, very small ones.
No, we have here lead number
Oh, I'm on
2.
my phone. I can't really see.
Well, look, you should use a laptop or a PC at least to see it. But yeah. Okay. So it meaning that we do have P wave positive in lead number 2 and negative in AVR. So that can be a sinus rhythm. Okay. Let's look at how, let's see, long the PR interval. It's less than 0.2. So that's meaning that the AV conduction is normal. Good.
Okay.
Next is the Qrs complex. Okay. Is it wide?
No.
Okay, you don't see it on phone. Yes, for sure. 1, 2, 3, 4. Yes, it's wide.
Okay.
It's about 0.16 seconds, so it's wide. What does it indicate? It can be a sign of a intraventricular conduction abnormality.
Okay.
So, which one? Right or left?
I don't know. How would I say? I really don't know.
Okay. Do you see wide R wave in V1? No, you don't. You do see in V6, and especially is a nudged one, so it can be a left bundle branch block.
Okay.
Next one. Do you see pathological Q waves? Especially you don't see it on your phone. Lead number 2, 3, AVF. Yes, we do. Okay, but there is no ST changes and no T changes, so that can be an inferior old myocardial MI. Now, look at the size of the R wave in V5. How many millimeters? That's 10, around 21. Plus, if you summarize 21 plus, let's see, this 31 plus 7 is 38 millimeters. So that's meaning that we could have a left ventricular hypertrophy as well. Okay? Good. All right. Let's see this one. Now, who is going to solve this ECG? Whoever practiced a little bit, please. Who is that one? Who studied for today? Nobody. How fast? You still have problem with your microphone? Especially maybe you are on the phone. Okay. J. Come on, somebody, please.
I could try.
Oh, finally, you are a brave girl. All right, let's see.
I would say it is rhythmic.
Okay, good. All right, it's rhythmic.
The heart rate is typically about 100 or a bit less
Okay,
than 100.
1, 2, 3, and more than 3, so it should be less than 100, not?
Right.
It's between
About
75 and 100, so it can be 80, for
80.
example.
Okay.
Okay, good. So it's normal. All right.
Mhm.
Do we have P waves?
Yes, based on the
Yes, in
group
lead
1,
number 2,
I-
we have positivity, lead number 2 positive, and AVR is negative, yes. And every P followed by QRS complex, okay? So we do have a sinus rhythm. Okay, go on. QRS complex
the PR
is
narrow.
narrow.
PR interval is normal. QRS
Yes, we said
complex
it.
is not narrow.
Why? Why?
Oh.
What is the problem with the QRS complex?
It's
I
wider.
think,
than
no, it's not.
expected.
Why?
Why?
Look, this is about 2 millimeters. It's 0.08 second. It's normal. If you come here, it's still okay because you have to look at from this point to this point, and it's still okay. Yes? So it's not wide. This
Oh, okay.
Q,
Okay.
so these QRS are okay. That's meaning, oops, oh, shoot. Okay, so this QRS is narrow, all right? What about the axis? One is positive, AVF is negative. Lead number 2 is negative, okay? So the axis is, oops, oh, shoot. So the axis is
Extreme left deviation.
exactly extreme left deviation. So it's less than minus 30. Good. Next one. Do we have pathological Q waves? Yes, we do.
Yes.
Lead number 2, 3, and AVF. Yes?
Mhm.
Yes? Can
And
you
then
see
we
it?
have, yes.
Okay. And we do have ST elevation, the same areas. So what does it indicate?
That would be the acute myocardial infarction.
What is a location?
Inferior.
Exactly. So we do have an inferior acute myocardial infarction. Okay. But if we do have, oh, shoot. If we do have an acute, come on. Oh, Jesus. And if we do have an inferior MI, we could have posterior. Can you see any sign of posterior? See how tall the R wave is here. Again, very similar to the previous one. In V2, the R is bigger than an S wave. And in V3 again. So again, we have prominent R waves, plus we do have ST depression. Yes, can you see it?
Yes, we can.
Okay, it indicating that we do have an acute infero-posterior acute myocardial infarction. Now, if you're looking at, very difficult to see it, but this is the top of the R wave. See, this tall, the R is here. See, it's very, very tall, very tall. So that could indicate a left ventricular hypertrophy. Okay.
Based on the R height of the R, you're saying.
Exactly. This is, yeah. Okay, guys. So please, I'm begging you, watch all videos and practice. This is why I send you the link and download these tracings and practice. It's not that, of course, the theory is only the basic thing that you have to know.